Hi guys, welcome to the Geography Academy. This is Unit 3 Hazardous Environments and it's part 1 of 3. It's covering the tropical storm section. So tropical storms are studied in lots of different geography curricula, but this one is making sure it hits all the points for Edexcel, IGCSE in particular, but it could be super helpful for you as well if you're doing another curriculum. Okay, so let's get started. Subscribe for more content, and also down below I've left links to anything else that could help you out. So there's 3 sections: tropical storms, volcanoes and earthquakes. We're going to cover everything in tropical storms right here, including the impacts and the one case study that you need. We'll actually have a look at 2 contrasting case studies, just have a look at a more or less developed country. In the syllabus, if you want to pause and have a look at it, this is the list of things that they expect you to know, but we're going to go through all this in this video now, and yeah, you don't need to learn this or anything. Okay, just quick definition getting started. A natural hazard then is the physical hazard itself: lava flow from a volcano, wind from a tropical storm, seismic waves from an earthquake. Natural disaster is then how those hazards impact people and the environment, right? So if there was nobody around or nothing in the environment was damaged, it would be a natural hazard, but not a natural disaster. We're going to start off with tropical storms by looking at the physical processes that cause tropical storms. Now, what's very important to this one is learning and understanding what low pressure systems are. These are large scale hazards, the tropical storms, different to tornadoes, which are very small, similar but much larger than things like thunderstorms. So we start with low pressure. How does this tropical storm begin to form into this massive storm cell? So the concept is like this: we have different types of air pressure all around the world, and with that air pressure then comes different reactions. We've got high pressure and we have low pressure. The tropical cyclone is a low pressure system. So what's happening is an area has surplus energy or surplus amount of heat, and that heat then is going to build in an area. Now, as this is building, the air expands, so the air rises. So you all would have heard this in school. This is just like primary school, secondary school. This is a more complicated version, slightly. So basically the air rises. As it's rising, it cools and condenses. It'll form precipitation in these areas of low pressure. So that's something you would have learned before, but now there's a name to it, okay? So low pressure, air is rising, it's becoming less dense, rising, condensing into cloud and causing precipitation. In areas of high pressure, then the opposite is happening, where the air is moving down, and then there's this area in between them where the air from high pressure moves into the area of low pressure. So this means that as the low pressure continues to rise, it's going to drag in air from around it, bringing in any moisture, any heat energy with it, and causes that to rise too. Now, if you haven't understood this, I would suggest stopping and just going back over that again. And we'll just do a quick recap again, that low pressure is less dense, which means it rises up easier, like a hot air balloon. And as it's rising, it's going to cool and condense into clouds up here, and this will cause potentially precipitation. And as you have probably guessed, this then builds into potentially a tropical cyclone as well. So low pressure areas, air rising, and bringing heat and moisture into that area and up into the air is what's driving the force of the tropical storm. So we can see this happening in certain regions that has a surplus of energy. Anywhere there that's coming in roughly around 26 degrees Celsius and above, we're going to see there around the central region. So you should know at this stage that the line roughly the running through there is the equator, and a little bit north and south of that we can see the most heat that's actually appearing in those areas. So it's that heat that creates a low pressure system around this region, and that low pressure system has the potential then to become a tropical storm, just depending where it is and other influencing factors. But for sure, this is where we see low pressure systems forming. So let's go through it here step by step. In an area of low pressure, about 0 to 5 degrees north and south of the equator, the rising air produces a thunderstorm, right? So that's a low pressure system starting here. It's a very localized one. This is a very small one, where we see air rising up very high into the top of the atmosphere and producing these big clouds that kind of form and follow the top of the atmosphere there. And this produces very large storm systems. Now, this usually happens at the end of the summer in either hemisphere. So northern, southern hemisphere have different summers, for example. And this is because the oceans get to heat up the most. So they're at their maximum temperature. So around sort of like September, October, we're going to see this area here being super high in terms of its temperature. And then temperatures down here, maybe later in the year, are going to be very high. So this means that tropical storms will appear on both sides at different times of the year. So we need that heat, that intense heat from the ocean. We need low pressure system, air rising. And as the air is rising, then it's going to be rising over a very warm ocean. So this is very important. It causes unstable air. The ocean is usually greater than 26 degrees Celsius in terms of its temperature. And this means that heat and moisture is now rising. So it's rising in to make a big thunderstorm, and this may become more long-term into a tropical cyclone, and then it can continue to build. So it all starts from the idea of low pressure system. Warm moist air coming from the heated oceans is rising into there, and then this rises up, forming a storm system. So that's the beginning of a tropical storm formation. Pause here, have a look back over it, make sure you fully understand it before moving on, or you might find it a bit more complicated. Okay, so now we'll have a look into the structure of the tropical storm itself. So how does it go from starting as a depression or a thunderstorm and growing then, the consolidation of the cyclone system? So we see that in the center, we're going to find our low pressure somewhere around here. So air is moving in from all around. And as we said, this is bringing moisture and heat, which is the energy that's causing it to form. And we see it rising up in different bands as well. So the air is warming up, rising in different bands, rising here as well, kind of in a swirling motion. And this creates the eye, and the eye creates the strongest wind. And what we can actually see is it's not just low pressure, but actually in the middle, there's an area of high pressure. So before we said high pressure is no clouds, air descending. So the difference between the high and the low pressure right beside each other in that eye means that it creates a bigger difference between the two, and the air speeds up. So that increases the wind speed and continues to encourage warm, moist air to move into the low pressure area. Now the storm itself, because the wind speeds are moving differently as they go up, so wind speeds can be a little bit faster in places, slower in places, and what happens then is we're going to see the change then in this wind shear causes the storm to spin, as one area is going to move faster than the other. This causes it to spin counterclockwise in the northern hemisphere, clockwise in the southern hemisphere, right? So they're both having the same process happening, but because the earth is spinning and the north and southern hemisphere react differently to that, which is our next point now. So just adding in that factor, we will put that all together. So the formation down to the idea of a tropical cyclone forming with the low pressure and the warm ocean temperatures, to it being consolidated now into a system, a structure that's able to grow over the oceans. And we see some of the key characteristics there of that, like the actual way it's spinning and the eye formation as well. But not only is it spinning, but it's sort of moving away from its original destination. So if we're looking at this one here, you can see from a 2009 tropical depression. And as we're seeing this coming in, we see that it starts moving away from the equator, right? It's kind of like veering to the right of its original course, or looking at it going to the northwest, right? So this is happening because of the Coriolis effect. Similar reason to why the air won't move at the same speed. And it starts spinning, but also the physical storm itself, the entire storm, is moving away from the equator. So if we imagine the equator just around here, roughly, and what's going on now is that this low pressure system begins as maybe a depression and then it gets upgraded to a tropical storm a little further away. Tropical storm, and then it continues to grow because everything that is moving in terms of the wind is going to be moving and veering away from the equator. And that's why we don't actually really see full-size tropical storms developing or tropical cyclones, I should say, developing right on the equator, but usually it's a couple of degrees north and south. So in the northern hemisphere, the spinning of the world will cause the storms to move to the the northwest, I should say. And then in the southern hemisphere, it's going to move in the opposite direction. So if you pull up any maps, you'll see it's quite similar, and we can see in most places it follows this rule. We won't always get it in every area, but yeah, areas with warm oceans will also see these coming in from the ocean onto land. Okay, so that is the Coriolis effect. It's the impact of a rotating sphere and how the wind is reacting on top. So it just causes the wind to veer away to the right of its course or the left of its course in the southern hemisphere. Now, we've already mentioned then all of these. You should be able to understand them so far, how it intensifies and consolidates. We've mentioned it spinning clockwise and counterclockwise, and we've talked about the Coriolis effect impacting the direction of the movement of the tropical cyclone. So these are all the points that you have to understand to be able to explain its formation, but also to explain its distribution, okay, and the path that it follows and where we find it. So let's have a quick look at that. We don't find it in every single ocean, so there's some areas here where we don't typically get tropical storms. We're looking over the last, or kind of like 45 to 2006 there, so it's forming a pretty consistent pattern. There's none here because we might have too cold a current, for example, is one of the main reasons, so the oceans aren't getting up high enough temperatures to build up. And we can also note that not very many have become, say, hurricanes category 1 to 5 in the equator. Now, we've been talking about tropical cyclones, but another name for tropical cyclones is hurricanes. You'll also see it written as typhoons. They can be categorized from 1 to 5 on the saffir-simpson hurricane scale, which we'll have a look at in a moment. But let's look at the trends in terms of the distribution. This is also a skill that IGCSE Edexcel wants you to have. Is to look at a world map and be able to both describe and explain the distribution of these tropical cyclones. So we can see them beginning as a depression and a tropical storm closer to the equator, and then they are moving away. So they follow the same trend, different times a year, but they're following very similar trends here. In the northern hemisphere, for example, in the northern hemisphere, we're going to see it beginning at the equator, veering up to the northwest. And yeah, we see it starting out in the sea where it's quite warm in the equator, then moving up in that way due to the Coriolis effect. So you should be able to describe that motion of coming from that area, especially where they have a long run of ocean and it has time to heat up, it has time to build up and become much, much stronger. So bigger bodies of water are going to allow for that. Same in the southern hemisphere as well. Exact same thing happening with the Coriolis effect, starting from roughly the equator. Large bodies of water with uninterrupted, well, it doesn't have huge continents, it'll have islands out there, but it doesn't have huge continents to block it. So what do we mean by blocking it? Well, you'll see also the trend that not many of them stay very strong inland, right? So they hit the coastline all right, but then they immediately go down in the grade of power down to tropical storm and depression. So if we think about it, one of the biggest things that we needed for the tropical storm to start was warm oceans of 26 degrees Celsius. So this creates energy, the energy needed from the heat and the moisture rising to be able to fuel the growth and stabilize and grow the tropical cyclone. So without that warm water, it then dissipates and yeah, it just reduces in size and scale. Also, we can see some of them will travel across into other areas. Different types of currents will take them then, and they'll veer away into these regions. So regions like Europe will still feel, they'll call it like the tail of a hurricane or some hurricane low pressure system is still traveling across the Atlantic, but it's nowhere near as strong as it is when it's at that category 3, 4, 5 stage, closer to that area. Okay, so that's the general distribution of tropical cyclones. If you understand the first section, you should understand this map fairly well. So again, if you're just going through and revising but you haven't understood something, go back, learn it, and then continue. Now, so that's it there. We have the tropical storm. The tropical cyclone will lose its energy, diminish as it reaches higher latitudes and moves over land masses. Alright, so that's just a continuation of our explanation. Now, the second part we want to look at is looking at the impacts of these hazards. We've looked at the physical formation, the distribution, and some off the scale. So let's look at the three main hazards that we associate with tropical cyclones. We have high wind speeds, which are going to destroy infrastructure, lots of power lines, parts of buildings, signposts, lamps. All of these things then are very prone to blow over in the wind. Falling trees can do a huge amount of damage. And during a natural disaster, things like power cuts and communications being down can be really critical. Also, destroying crops in farms can lead to actually prolonged food shortages as well, which means they have to maybe rely on some charity and some food supplies being brought in as aid. So when we're talking about wind speed, a category 5 is anything greater than 252 kilometers per hour, which is incredibly fast. So it's a very high wind, and it can go way beyond that. That is just the highest to get into the highest category. It doesn't mean that it's going to stop there at its maximum, so it can continue to grow. Precipitation, then, there's two dangers that come with precipitation. One is that it's such a high volume. It's such a huge storm system with a huge volume of precipitation. So over a short period of time, precipitation at such a high volume can then cause things like riverbanks to burst, dams can be overwhelmed, and maybe they have to release floodgates. You would see very quick runoff, which means that the water can't get into the soil, the vegetation doesn't have time to absorb it either. So that creates floods, definitely, and very destructive power from the tropical cyclone, but also a prolonged period of rain. So if it's raining yesterday, if we just look at the anatomy really of the tropical storm back here. So let's say we're here and the storm is moving this way. So first we're going to feel this band of rain, and then this one. And maybe at this stage, all our stores are full. Like the soil is full, is completely saturated. Maybe the dams and the flood preventative methods that are in place can't withstand any more precipitation. But then day 3 comes and we get another band, a much bigger one again. And then finally we're getting these huge central area too. And even after it's passed through, it could still continue to rain over these days. So all the stores, all the places that water usually go into the drains, and wherever you might think about in an urban area or in the natural environment, will be completely overwhelmed. So that even if it's able to take a lot of precipitation over many days, a lot of the systems will be completely overwhelmed and will cause massive flooding. Now, all of this moisture as well is going to be very dangerous and lead to potentially more landslides, because the water gets into the slope and it decreases that slope stability. So it's quite well recorded for a lot of landslides to occur during tropical storms. The other one is a storm surge. Now, this is not a picture of a tropical cyclone happening, but during periods of low atmospheric pressure, right? So the air is rising, but it also allows the sea level to rise slightly just underneath it. So this means that you've got this bulge of water that's bigger than normal, and it's moving towards the coastline. You have prolonged winds, and winds are what cause wave heights, right? So the bigger the wind, the larger the waves are going to be and the more destructive they're going to be. And again, if you imagine it, as the tropical storm is moving in over multiple days, the wind speed closer to the eye of the storm is going to be getting stronger and stronger. So we see these wave surges where the waves with the low pressure is going to get too great, and the waves are going to be breaking much further in than they normally would, and they're going to start occupying areas way past where the coastline normally would be. Okay, so now it's able to go up and over this coastline here, for instance. Now, as it's doing that, I use this picture because what can often happen is this can cause one, severe flooding just by the waves occupying this whole region. So that's the first way that it's going to damage an area. But the second is that if the power of the ocean coming in is stronger than the river trying to leave, then all the water from the river will spread out and flood the surrounding areas also. So blocking estuaries, which is this, where the river usually leaves the land, it ends up blocking the estuary and causing huge floods in those areas too. So that is the storm surge. So precipitation, wind speed, storm surges, they're the primary hazards that do the most damage. Secondary hazards then are things that happen as a result of those that can create their own hazards and danger. Definitely water contamination is a big issue. So diseases such as cholera, dengue fever, malaria can definitely spread much more when you have those large volumes of water around. Freshwater resources then and stores are going to be affected, including things like sewage systems. Okay, maybe they will break down and add to the water. So this can create disease problems. Long term then it can create huge agricultural problems because the water is contaminated. It can also lead to salt water going into the soil and into the ground, and this is known as saltwater intrusion, and this can decrease the fertility of the land and the availability of fresh water to the people. Crime and poverty then is mentioned because you can get things like people are vulnerable. You might not be able to get so much emergency services out maybe to help. Police can't access your area. So people could be much more vulnerable to things like assault, robberies, these types of things. And also just things like malnutrition from not having enough food. A lot of people could lose their jobs or their livelihoods and not have access to food as normal. A lot of people have to rely on aid during this time as well. So this can be a secondary hazard that comes with the impacts of the primary hazards. And then finally, we mentioned greater risk of landslides, but more landslides and more rapid erosion can happen in the sort of the months then that's coming afterwards. But also we can see that, other disasters might happen. There might be another tropical storm, maybe an earthquake happens and suddenly there's an extremely large amount of landslides because it was weakened through previous days, maybe with the hurricane or the tropical storm. So it can have very long-term high-risk areas it can create then as a secondary hazard. So if we're looking at this for the categories we mentioned before, the saffir-simpson hurricane scale then used for that, different categories from 1 to 5, and we can see that the wind speed increases each time to get into that category. So it has to be 119 kilometers per hour to get into a category 1. And we can see there that they have anticipated storm surges. It's not always the case that these will match perfectly with the wind speeds, but the wind speeds give it the categorization, and we would be expecting storm surges like that. So we can see with a category 5, it's 5.5 meters or above. And we would think that it would be catastrophic defined as that, and a lot of structures would be broken and a lot of natural vegetation would be broken, and the storm surge will cause a huge amount of damage. So that just gives you an idea then of the different size and the amount of damage that each of these can do. Coming into short-term impacts then, we've divided it into social, economical, environmental and political. So SEEP is this way in which we talk about the causes of things and the impacts of things. More useful in human geography, but can be used when we're talking about human interaction with the physical landscape. So for social, we look at short-term impacts. So loss of life is the major one to begin with, and injury, homelessness, for example, or displacement due to people being forced due to floodwaters or the inability then to protect the home against floods. Economic losses then come in many different ways. So we're talking about businesses closing, people having to pay back for homes, public infrastructure that will be destroyed. But over the short term, we would be concentrating on money loss, so any type of trade that has to stop at that time. Agricultural damage as an industry finds that destroyed crops, but also land being lost due to floods, may remove land for livestock, like animals, and also the high winds, precipitation, and flooding then can cause destruction of crops too. With agriculture, there's also a short-term period in which they're able to actually transport their goods and trade their goods. So that period then could be lost, and then they lose the ability to trade their goods. Environmental, we see flooding. Obviously, that's going to make a big impact there. We have soil and degradation of habitats overall in wildlife. So anything that has to do with them moving or migrating and the habitat being lost itself would be a factor for that over the short term. That can also be a long-term one as well. Coastal erosion then can pick up during those times, so areas will be reshaped and there'll be an increase in destructive waves which can increase the erosion rate of the coastline there, so we might see a bigger loss during that time. Habitat destruction then can be both short-term and long-term, just depending on the extent to which it is damaged. Political, then we can see that a huge cost comes at the expense of the government, and they have to go through the rehabilitation. But also then on the short term, they have to organize stores, and they have to receive aid from different countries, and this allows them then to recover in the short term, to reduce the loss of life and the exposure to things like disease. Long-term impacts then, reconstruction overall, long-term projects, road, railway, then airports, schools, these types of things are major projects that takes a long time to rebuild. Also, they'll have to rebuild the defences and look into hazard mapping and rebuild in a more efficient manner. Mental health issues then can be quite long-lived, so we think about the amount of deaths that are in the area and injuries and the challenge that comes with this. Mental health issues then can be very long-term for many people. It's a very traumatic, stressed time, and it can lead to a lot of help being needed in the long term. Malnutrition then can cause a slow decrease in the quality of life as well, as we talked about, like food. Like say if the food stores are destroyed due to the hazard, and then later as a kind of long-term impact as that malnutrition takes hold of the area too. Saltwater intrusion then, we mentioned this before as being one of the big impacts, and this can impact the freshwater system, damage the crops, and it can decrease the food production for a long period of time and people's access to freshwater stores too. Overall habitat destruction like coastal ecosystems, coral reefs, mangroves, salt marshes, they can all be impacted for a long period of time, and this has a very negative effect on the biodiversity and can take a long time to naturally recover. Tourism then is quite a big industry in tropical regions, and some areas might be heavily reliant on that. So if there is to be a massive natural disaster, there's a lack of resources, infrastructure is destroyed, we have people with the loss of life, the spread of disease, malnutrition. All of these things then will stop tourists from traveling to the area, which might make up a large percentage of their GDP. So if we're looking into case studies then, we've got two major ones. We'll look at one developed country, one less developed country. And if we're looking at this, we'll start with the USA, which is a HIC, a high income country, with 26,000 USD per person, or GDP per capita. Now, when it formed, Katrina formed there, we can see it in the light blue when it is a tropical depression, and then as the colors get darker into the red, we can follow that track and see it increase into a hurricane. So it was able to grow into a hurricane category 5, but then weakened slightly before it made landfall there in this central area. So we see it just decreasing a couple of dots, couple of days before it makes landfall there. So there was a large amount of precipitation preceding it, and as we see that the levees and the flood protection system then were overrun. And this showed us that they were a little bit underprepared in terms of their preparation, and the age of these protection programs with levees and flood protection schemes were a little outdated and were overwhelmed with a very large storm surge of up to 8 meters. So an inability then to protect against the storm surge mixed with a lot of flat, low-lying areas in this region meant that the storm surge was able to pass and carry into the landscape quite a lot. The humanitarian crisis then, the short-term impacts, we can see here on the image how far the water was able to actually move inland and impact these areas completely. A lot of people were killed, so 1,800 is a very high death toll for a natural disaster, and over 1 million people displaced, meaning that they couldn't use their own homes, they had to move temporarily. Economic cost was very high, coming into 125 billion, and has seen this in the short term. This was quite a large impact, of course, because all these businesses and everything were destroyed and people's homes were destroyed, but this has lasted a long time, so that total cost is over a longer period as well. And we see that 80% of the city of New Orleans, which was completely flooded. So coastal impacts there, we also see that the wetlands and the barrier islands that protected areas naturally against floods were also destroyed at the same time. Long-term impacts, then we got the survivors suffering from PTSD, what we talked about before in terms of long-term impacts. The total cost then continued to rise up to a total of 125 billion. So this is a long-term struggle. We have to imagine that people are going to be waiting for insurances for a long period of time. There's a lot of rebuilding. Not everything can happen all at once, even though it's a developed country. The scale is so high that it was very difficult to do this. We're also talking about an area of the USA which is not making that much money per capita. So this would be a poor region of the country. So not all people were able to completely rebuild straight away. So they're very much reliant on things like insurance and government help here as well. In the environmental impacts, then we see the floodwaters then contaminating with chemicals, sewage, different debris, which wouldn't clean up for quite a while. So water sources then being unreliable into the long term. Government responses was a short-term and long-term impact. So people were very critical that the federal response was very weak and that a lot of people were left in vulnerable positions for a very long period of time. And it was also, said that at the time that people coming from a lower economic class then obviously were treated a bit differently, and that help would have been received much, much faster in different regions. So that became a big talking point there and a criticism of the government for quite a while. So inadequate preparedness meant that their long-term protection and increase of the protection was paramount then to the region. So this means that the long-term impacts were a much greater amount of infrastructure had to be put in place. On the other side, we see the Philippines, much lower in GDP per capita at about 3,500. This was a Typhoon Haiyan. So we're talking about tropical cyclones, but the last one we called it Hurricane Katrina because of the region of the world it was in. And in this region, we're talking about cyclones, but we're mentioning them as typhoons. So it's all interchangeable terminology. The Philippines then, a lower GDP. We see this huge typhoon coming in. 7,000 people had died and 14 million people impacted. 1.5 million completely homeless and 600,000 displaced. So we can see there that the numbers completely overshadow the Katrina numbers by a long shot. Now we're talking about a very densely populated country, high population, less developed, meaning that they didn't have the protection, the evacuation means the same as the USA did. See that 6 million people lost their jobs, 30,000 boats were destroyed along the coastline. Outside of the Philippines, though, only 56 deaths. So this very, very, very particularly impacted the Philippines, even though it technically hit other countries. So a couple of reasons why it was so severe. One was the level of precipitation, which was incredibly high, and that's going up to 282 millimeters under 12 hours. This means that none of the stores, like the soil, groundwater store, any of that would have been able to take in a large enough amount of that water, so enormous floods were happening on land. Meanwhile, Category 5, 300 kilometers an hour, winds were tearing through these cities, and in these cities in like Tacloban, a lot of the housing then wasn't built to the same standard as places in the US, for example. So this creates higher risk then, because we have dense population and we have underdeveloped population. And when we talk about the storm surge, we're talking about a 7.5 meter storm surge coming into a city of 250,000 people. So it's a 7.5 meter storm surge, and Tacloban is about 5 meters above sea level, which means the entire city then was going to get flooded by the storm surge through coastal flooding. Areas then, a lot of people are living off subsistence fishing and farming, which means they have to work every day, and they have to work in the environment every day and go out and catch something or farm something. So both farming and fishing industries were destroyed there, as well as 1.14 million houses. So each of those houses then could have multiple people living in them. Now this is why we end up having so many people displaced and homeless during that time. The government as well was unable to really evacuate on that kind of a scale. There's less land to be able to get to. There's less areas that were set up in order for emergency shelter as well. And afterwards they looked into building sustainable building designs, but also having no build zones. So they realize that as a less developed country, they're hit extra hard because of the standard of their infrastructure, the warning system, and the evacuations. But on the other side, they realize that one of the best ways to handle this is not to build in dangerous areas moving forward, because they're not at that level of income where they're going to be able to build huge hard engineering projects for defense. Okay, so that pretty much ticks all the lists, including the skills of this section here. Next section, part 2, is going to be about volcanoes, and part 3 about earthquakes. Have a look below and see if you see any resources that might help you out. And of course, like and subscribe if you want me to make more of these videos. Thanks a lot, guys.